Hello there, welcome to another video in this channel, and today we are talking about agentic AI system workflows. Now this is part 2 of the video series and part 1 where we have covered about agentic systems and the workflow patterns that we have been discussing about this. And I would suggest anybody who hasn't seen that video, please go and see the video because that will have a continuation to this video. But I will summarize for you and what our agentic systems are. Now, according to Anthropic, which is a competitor to OpenAI, they have defined agentic system as an umbrella term, and under which there are two categories. One is a workflow and another one is an agent. So what are agents and workflows? Now, workflows, they have where the LLM actually follows a predefined code base or path. So it has a start and end, and it uses tools to use, so the LLM uses tools to finish a task or work. Now, on the opposite side, an agent, the LLM dynamically thinks about what is the task to complete, the steps to be taken. It uses feedback loops and it orchestrates the tool's usage or not according to itself. So it doesn't have a start or end, and it doesn't follow a predefined path. So in order to qualify a system to be called as agentic system, one has to have a workflow or agents or both. So that's the definition of agentic system. Now in this video, we are covering the design patterns of this agentic system workflows. Now, according to Anthropic again, it has identified 5 different types of agentic design agentic system workflow design pattern. And in the part 1 of the video, we have covered first two. One is prompt chaining and the second one is routing. And in this video, we will cover the remaining part of this agentic system workflows. And as always, we'll be building some use cases, solutions to showcase, to build. So the theory part is separate, and we'll build a practical and see how these design patterns actually work. Now, as a prerequisite, I would like to add that all these use cases that we'll be building hands-on, we'll be using it on n8n. But rather to say, these design patterns are universal. It is not part of n8n or make.com or Zapier. You can also code in Python to build these design patterns. So the reason why I'm using n8n is because I can actually showcase what the design pattern looks like and build accordingly, so that we can have an apple to apple comparison about the theory and the practical to it. So that's why we are building. So at the end of the day, again, let's summarize. At the end of the day, we already know what is an agentic system. We will also understand the remaining part of the design patterns of agentic system workflows, and we'll build some solutions to it. So I think it's going to be a very interesting video, and without further ado, let's begin. Okay guys, so as we discussed in the intro, we will start or go with the remaining design patterns of the agentic system workflows. And the third in our series, rather, is parallelization. What does it mean? And you will see many of these design patterns are very similar to each other. And I will say why it's similar, but there is some difference. Now, here in parallelization, you see the color codes where the yellows are LLMs and the blues are more of the codes, where we have here coordinator and aggregator. Now, if we go to routing, from our previous video, part 1, you would see routing is very similar, but here an LLM is routing to each of these specialized LLM for the specific task. But in parallelization, what is happening is there is a coordinator in place of LLM, which is a code itself, and it routes or segregates into subtasks, and then those subtasks goes into the specific LLMs. And then those outputs of each of these LLMs goes into aggregator, which stitches all the outputs together to give us a full solution to it. So in parallelization, the most important part is that even though these tasks are divided into subtasks, all these LLMs are actually concurrently working each other. So that means the subtasks in LLM 1, 2, 3 are specific tasks for that specific LLM, and they are working simultaneously and coming out with an aggregator. So we have the code which says what is the subtask to be. An LLM gets each of these subtasks, and then the aggregator stitches out all these subtasks into a final output. So that's parallelization, where we say break down task into running multiple subtasks concurrently. So concurrently is the key word here. It is simultaneously continuously working together. So now we'll go and see the into N8 and see the same output. And if you see here, there should be a striking difference that you would find that there are three LLMs. Here it is two, but the out thing is that you can add as many LLMs as you want depending on the subtask that you create. So that's the thing. Let's run first and see what the output comes in. I would say what to what is artificial general intelligence. Okay, let's just type in. It's running. If you see, it's concurrently running, and then we have got an output. Let's see the output first, and then we'll figure out what is happening. So you see, it's a demo name that I have given, and then the question is what's its artificial intelligence, and then there is a summary. It is a combination of part one and part two uh, of the LLMs. And if you see where I say model 1 response is here, which says what is AGI, and part 2 or LLM model 2 response is like it says understand the human cognition or the risk and mitigations to it. Now let's deep dive into each of the nodes to understand further. Okay, so they have given a trigger, and then the coordinator I'm saying is that based on I'm just putting a manual mapping to this coordinator and then saying what is a artificial general intelligence. Now each of these LLMs, now what I have said, I am using a Gemini 2.0 Flash 2.5, and I'm saying that if you see defined below, and I'm just giving what is AGI, but in the system message I'm saying you are a GPT-4 style AI. Provide a clear, technical, and precise 2-3 sentences. You will focus on topic summary. So I'm just asking to define what is this, and it has given me an output over here. On the LLM2, I am using I'm coming to the model, but if you see, I'm saying same, but here I'm saying your GPT style AI provide well detailed reason answer 2 to 3 sentence and will focus on risk and mitigation. So the subtask that I have set in this LLM is to figure out the risk and the mitigations for artificial general intelligence, whereas the LLM1 I have asked what is the actual summary to it. So that's the two tasks that I have given. Here the aggregator takes those inputs, combine into a summary output, what we saw the final output, and then there is a formatting that have been created. What is the question, model 1 response, model 2 response, and the summary in a tabular format, and then the output is what the trigger has given. In terms of the model, I am using GROQ, Grok with a Q, and the model is GPT OSS 120 billion model, which is open source. If you have not seen the video for how to generate APIs keys for free, any models, please have a look into those. You will get free API keys. You don't have to pay a single penny to utilize these LLMs. So there are free LLMs that we can use even with GPT OSS. So guys, that's parallelization. I understand this is a very small example, but you can actually figure out what are the other use cases that we can build. But ultimately, this is what parallelization is all about. Okay, the next design pattern is an orchestrator worker uh, design pattern. Here, so if you see, it's very similar to parallelization, but the difference here is the even everything is LLM. So in parallelization, if you see, the coordinator and aggregator are codes that we are saying what how the task to be distributed and broken down and given to each of these LLMs. But here, the orchestrator worker, the orchestrator chooses what task to be done and how what task to be given to which LLM, and then the synthesizer stitches the output together to give us a combined work. So here the main idea is that a complex task is broken down into multiple subtasks, and then it carries out into the LLM, and then synthesizes the synthesizer synthesizes all these outputs of the subtask by the LLMs into one single output. So that's orchestrator worker pattern, design pattern for you. There is no codes that we are using, it's all LLMs. Let's go to N8 and create something. So if you see, I've created this orchestrator worker, and it's very similar to the only difference is I have given two subtasks, not multiple. So we can add multiple subtasks definitely, as we saw in our earlier parallelization also we spoken about. So let's just run first. uh, we'll use this same example, explain artificial intelligence. And you see the orchestrator is running, worker 1 is running, worker 2 is running. It collects, and the synthesizer is combining all the outputs, and now we will get an output here. It says, let me maximize the screen and explain artificial intelligence. Final result: artificial intelligence involves development of computer system designed beyond the fundamental definition and objectives, narrow AI or weak AI, general AI, super AI. Okay, so it has a definition, and there are some subtopics or fundamental definitions, objectives or example, rather example. So narrow AI, what type of example; general AI, what type of examples; and super AI, what type of examples it has come up. So now let's see how this is created. So this is a chat window. Let's see what the orchestrator LLM speaks about. So here I'm saying break this task. The task is the explain artificial intelligence into two specific subtasks. Tasks, it's that which we are taking, and then it's saying task one first subtask description, first task two description. And what does it mean is that you see the LLM has defined the task. So we are not defining any task based on the codes. It's the LLM is defining what task. And task one is provide a concise definition of artificial intelligence outlining its core principles and goals. And task two is illustrate key types of AI, example narrow, general, super, and common applications with simple example. So you see, we have not done anything. We just created an orchestrator, and the task that we have defined, because we said two tasks, so it has created two tasks for us, for the LLM workers to work on. So now we are actually using a parsing task, because we need to showcase that task 1 and task 2. So this is the code to break task 1 and task 2 for both the LLMs, worker LLMs. Now worker 1 gets task 1, and it says complete this subtask in 2 to 3 sentences. Subtask is from the first task 1 has gone. And it says artificial, it has given an output, the definitions of artificial intelligence. I'm not running going through that. And worker 2 has got uh, sorry worker 2 has got task 2, and it has given the types of AI, the narrow AI, the like voice assistance, general AI, uh, and then super AI, right? All these examples it has created. And then we are taking all these outputs, the connecting into two together, and parsing for synthesis, because we have to it's not directly it has to come. There are some in between to these LLMs to connect the dots. So because we are passing two tasks, so the output also should be in two tasks, two outputs, and then these two output will be combined together by the synthesizer, which says that combine these two worker outputs into one cohesive response. Part 1 is output of worker 1, and part 2 is the output for worker 2, and then create a unified, well structured final response. So that's what the synthesizer does, and it has given such a nice output over here. And this is what we saw in our chat. Such a nicely it has given. So here you see I have used uh, Gemini and OpenAI model, which is GPT 4.1 mini. Uh, you can use 5 also, doesn't matter. But here you see how the orchestrator worker is working on multiple subtasks and then defining and then synthesizing to give us an output. So that was orchestrator worker, the fourth design pattern for you. Okay, so we are on our the last design pattern, which is the Evaluator Optimizer. Now here you see there are two LLMs which the output is validated by the other. So the first LLM is a generator which generates an output, and the second one is a synthesizer that actually enhances the output. Now here there are some arrows. If you see, one is a solution. So the generator output of the generator moves to the synthesizer, and then it actually looks into whether, based on the prompts that we have passed, whether the output matches with the context of the synthesizer's work. If not, then it is rejected with feedback, and then there is a loop, continuous loop, until the generator is able to generate a better response or better output to it. And then once it is accepted, the synthesizer, it will go to as an output, as a final output. So there is an LLM generator and a synthesizer, and this is what the evaluator and optimizer works. So it one LLM evaluates and then optimizes the output of the generated of the LLM. So that's evaluator generator for you. Let's go to N8 and see. Now this is the same thing what we have seen. We have a chat window. There is a generator, so we'll do a email drafting, and this email will be evaluated based on some qualities defined. If accepted, or revise, it will go back. If accepted, it goes straight away, or else it will be optimized back again to the and generated. So that's something. Let's just showcase. Maybe we'll just type in as uh, holiday leave. Let's see. So we just typed in holiday leave. The generator is trying to generate draft a response to the email, create an email, sorry. So now if you see, the evaluator is evaluating, and then it did not pass on the first stage, but we go into the optimizer and then it passed in. So let's go one by one and see what is happening. So it's this chat trigger. And okay, let's see the output, how it came in. So if you see holiday leave request, and it has given a very small precise email. We're not going to the email anyways. Let's go what happening inside this nodes, and just hide it out. So the first node, it says the generator, and here I am saying write a polite, concise and professional email based on the request, and the request was holiday leave. This is what it is supposed to generate. Okay, now if you see here, the output is generated, and the request leave starting from inclusive, let me know if it's the period works and I will need to complete additional paperwork. So it has given something. Now what happens to the next node? The evaluator comes in with the quality check. Here in the prompt we have said evaluate the following email from professionalism, clarity and tone email. That is the output of. So I always say that one LLM's output is another LLM's input, right? So the email is the input provided by the generator and respond only in JSON. And we're saying accept or revise feedback. If revise, explain what should improve. So it says it revise, explain what should improve. And if you see, it says accept the email is excellent and professional, citing that it's direct, polite, inclusive, all, and so it has accepted it, and there is no revision needed. It says so. It straight away goes to so the accept or reject part of it is here, and I say that if accept is equal to accept or equal to revise, so it's revise feedback is this email is correct, and the false branch goes in because you see the true is the false here. I made some kind of mistake over here precisely, but again, so that true part, that accept part, goes to the optimizer, and it says improve the email below using the evaluator feedback. Revise must be professional, clear, polite, and it evaluated with the feedback and all these things. Oh, sorry. Uh, once if it is not accepted, by the way. Yeah. So that's the loop, feedback loop, and the continuous generation. So this is only over when the output is based on the quality checks that happen. So if you see, the generator and the synthesizer keeps on looping itself until it is accepted by the synthesizer, then it is out. So that's what evaluator optimizer of the pattern is all about. I hope you understood a lot about these design patterns. uh, there is one caveat also just to add, is that these are 5 different patterns, but there are, you should be using on a hybrid manner, that one design pattern is not specific, right? You can combine multiple design patterns to create something, a singularity of it. So maybe you can create use prompt chaining after, where evaluator optimizer can be used. So combining evaluator optimizer with prompt chaining to it, routing to it, and adding so many things that we can add onto it. So that was the video all about. I think you learned about, and there is a solid foundation of about agentic system and the design patterns to create a agentic system workflow. And thank you. We'll see you on another video.